In this module, we're going to learn about the WCF receive adapters, a special class of adapters that are focused on receiving messages using web service protocols and built on the Windows Communication Foundation framework. In the first lesson, we're going to get an introduction to the WCF receive adapters. You'll learn about WCF in general and how those adapters build on top of that. In other words, how BizTalk and Windows Communication Foundation technologies are combined. In the second lesson, we'll take a look at the mechanics of configuring a WCF receive adapter so that you can understand the different steps and the processes involved in setting up a receive location to use one of these adapters. Finally, in lesson 3, we'll take a look at the WCF service publishing wizard, which has the goal of making it easier for you to create those receive locations and any other artifacts that you might need to publish your service so that others can consume it and can pull down web service metadata. The first lesson, we'll take a look at Windows Communication Foundation to make sure that you understand what it is. We'll look at the web service standard support provided in the latest version, WCF version 4, which is the version used by BizTalk Server 2010. And then we'll see some of the particular scenarios where the WCF receive adapters can be especially useful and where they can enhance your enterprise service scenario. We'll take a look at a particular scenario, and then we'll finish off by looking at the WCF receive adapter architecture. So we'll see the mechanics of how WCF integrates with the BizTalk receive locations and all the pieces that make up that process in terms of pipelines and adapters. Windows Communication Foundation is a framework that's part of .NET, and it's focused on message-based applications or service-oriented applications. What WCF allows you to do is build distributed applications where WCF's focus is on the messaging or the exchanging of data and logic between different nodes of the application. It's very much a service-oriented technology. It supports SOAP and many other features of web service technologies, but it's also at its core really a messaging technology, which makes it a great fit for working with BizTalk. Now, Windows Communication Foundation was first released in .NET 3, had some updates in .NET 3.5, and then in .NET 4 also got some enhancements and improvements to various parts of the framework. When we think about WCF and its goal, we have this notion of both a service and a client. And when we write services in WCF, we're really talking about writing these application units or pieces of code that provide a set of operations or features and that are focused on a message-oriented communication, receiving messages, processing those messages, and oftentimes returning a message with some sort of results. Like BizTalk, WCF focuses on sharing contracts. A contract for the message would be a schema. The contract for the operations that it supports is called WSDL, or Web Service Description Language, WSDL. The schema, the Web Service Description Language are all standard protocols and standard message-oriented features that other services provide, and WCF and BizTalk provide those as well. Now, WCF is the most modern framework for Microsoft for doing web services. It provides many different transport protocols such as TCP, named pipes, MSMQ, and of course HTTP. It also supports many different flavors of security, including Windows-based security, as well as transport security such as basic authentication in HTTP or certificates, and supports all of the security specifications that go along with interoperable web service protocols. Has a built-in configuration system to separate out the concerns of the actual listening endpoints and the protocols you're going to use from the business logic and the code that you want to write. And of course, fully supports metadata to describe what operations the service provides. In WCF version 4, the framework itself supports many interoperable standards, protocols, and standards that have been set by various bodies that are not just Microsoft specific, but have participation from many different vendors and define really the protocols that go on top of the basic messaging. SOAP really provided a common format for exchanging messages where there's a body and a header, and that was the majority of what SOAP did. What all of these additional specifications provide on top of that is really how to leverage the headers. The body has always been primarily about the data you're exchanging, and the headers were really intended for this kind of protocol exchange, things that were outside of the message. And so we have things like WS addressing, which helps provide a standard around how messages are labeled for their ultimate destination. And for routing, we have WS Atomic Transactions, which provides specifications around interoperable negotiation and setup of distributed transactions so that we could have a Microsoft distributed transaction coordinator speaking to a transaction coordinator on another system. We have WS Coordination around things like workflow and those sorts of things where we want to define a protocol for laying out the coordinated exchanges. We have WS Metadata Exchange for exchanging metadata over SOAP requests. WS Policy defines a common way to lay out the various requirements of a service in terms of its security requirements, for example. WS Reliable Messaging adds in an acknowledgement system and a notion of sequencing of messages so that we can make sure we get only once delivery and that we have the notion of dropped messages being retried. WS Secure Conversation provides a ability to create security tokens and have one particular security handshake up front and then use the security token throughout a conversation so that the overhead of initiating the security is limited. That builds on WS Security, which lays the foundation for a lot of the security pieces and identifies how messages can be encrypted and signed. Of course, we have policy around that with WS Security Policy, and we have WS Trust, which helps us build up federated security options. So these are the bulk of the specifications that are out there and in heavy use today, and BizTalk through WCF now can support all of these different protocols. The standards organizations have also defined basic or profiles that lay out the compatibility or set of these specifications together, and services then can declare support for particular profiles. So we can see that in WCF we've got a wide range of support here again for the basic profile and various versions of that up to version 2.0. We've got a basic secure profile. It adds in security in there, reliable messaging, and then we have a reliable secure message exchange. Now, BizTalk, or WCF rather, has not implemented the latest versions of the WS Reliable Messaging and some other things, but as we get into how WCF works with BizTalk, we'll see that that may not be a big concern. And so WCF, through all its support for these various specifications and profiles, allows BizTalk now to take advantage of all these things to interoperate with services and clients that leverage these different specifications or that support these various profiles. As you think about a BizTalk installation and the various systems that BizTalk may interact with, one of the key things to understand about the WCF receive adapters is they provide just one more way to receive messages into BizTalk server. So while you can see here that the ERP system based on maybe an Oracle is sending in particular messages, and we might get messages from SQL Server, we can also receive messages through web services. The benefit of this is that we open up all of those different protocols and all the different security options that go along with that. By leveraging web services, we're now taking advantage of a framework or a messaging communication platform that many other systems, partners will be able to use to send us information. So it opens up many different opportunities for receiving messages into BizTalk server. We think about a particular scenario there. We might have our business process orchestration out there that's processing orders. We have the web services capability now, so that not only can we receive purchase orders, but we can have many different exchanges over these web service communications. So we can broaden the reach of our BizTalk server infrastructure out through the internet, perhaps, to our vendors, to manufacturing, to accounting systems, so that we can take our purchase order process and not have it simply be focused on our internal systems. We'll still have internal systems. Those may use proprietary protocols and libraries. Some of those may use web services, such as those offered through WCF, to allow us to receive messages from those systems. But we can also, now that we have a standard messaging adapter that's exposable over the internet, we can now also broaden that out to many different packages, many different partners who can communicate with us through those web service protocols securely and reliably over the internet. BizTalk and WCF are integrated at the adapter level. And what that means is that messages come into BizTalk through the WCF receive adapter. That's the piece of new code that we have here. Inside that adapter, which implements all the appropriate interfaces and looks like an adapter to BizTalk, there's a thing called a BizTalk service host. Now, this is a WCF component. It's the core component you use when hosting a service. And what it will do is host a very generic service inside that adapter. When messages then arrive at that service where it's listening on those different protocols like TCP or HTTP, the message is first processed through the WCF infrastructure with its channel layer that includes the various protocols like security and reliable messaging and transaction support. And then the adapter, like any other adapter, will take that WCF message, convert it into a BizTalk message object, and pass it into the receive pipeline where additional processing can take place. So we can have decompression, we could have our message disassembly or validation, and then the message gets published into the message box database. So this is how the two technologies are combined together. It happens out there in the adapter, and essentially the WCF adapters host WCF endpoints within the BizTalk process or out in IIS in some cases, and allow both sets of technologies, both WCF and BizTalk, to process messages at the appropriate level and with all the flexibility and the power that each of those frameworks brings. In this second lesson, we'll take a look at configuring the WCF receive adapter. We'll look at the various steps that are involved in setting up a receive adapter within your receive location. We'll talk about the different types of WCF adapters or the different flavors. We'll see how you can select message content, which is a unique feature that the WCF adapters provide that others do not, and how to then, if you've selected particular content, format it, and also look at not just one-way ports, but also two-way receive ports to see how the WCF adapter plays in with BizTalk in those scenarios. When you're on a receive location and you configure the WCF receive adapter, you're first going to select what kind of adapter you want. And you can see from the drop-down here that there are several different adapters available that start with WCF. I'll talk about those different types. You can see we have some with different protocols and different versions of protocol support. And then once you've done that, you want to select the particular address where that adapter is going to listen. And those might be virtual addresses for an IIS hosted adapter. They may be full physical addresses if you're using something like the NetTCP adapter. Once you've configured the address, you have the ability to configure other properties such as the binding properties. Here you can see example of setting on the binding settings such as the timeouts, the message encoding, or service throttling options. You can also see tabs for security that will allow you to set up the security requirements. Now these user interfaces, you'll notice at the top, are very specific. This is WCF Basic HTTP Transport Properties. They're focused on one particular adapter, one particular protocol, and therefore provide a constrained but very powerful and useful user interface for configuring those adapters. In BizTalk Server 2010, we have the set of adapters that you can see here, and we also have, dictated by their protocol and some of the settings, a particular type of host that we would use for those. WCF Net TCP uses something from WCF called the Net TCP binding that allows integration only with clients that use WCF. So this is a binding that is in settings that are only available and supported by clients that also use WCF. And you'll notice that anything that starts with net, such as the net SMMQ, the net named pipe, that same set of rules is true. Anything with net in the name like that is focused on a WCF client. So the WCF WS HTTP adapter uses the like-named binding in WCF, and this one provides us an HTTP transport and support for all the WS star protocols. That's a generic way of talking about all those different protocols that we saw earlier. WS security, WS trust, WS reliable messaging. Those protocols are known as a WS star. And so this this adapter can support those various protocols. Now that one is an isolated host because it's going to be hosted out in IIS to take advantage of all that IIS brings to hosting HTTP. Whereas the previous one, the NetTCP, you can see is hosted in process because it's focused on those WCF clients, a proprietary protocol, and not leveraging HTTP. We have the net named pipes. Those are great for a single machine cross-process communication. Again, an in-process host. We have the basic HTTP. This supports the basic profile and would integrate, for example, with the older .NET 2 web services frameworks, or give you the best interoperability with other client frameworks such as Java that may or may not support the various WS star security protocols. We have the net MSMQ. Again, this is for WCF clients only. We still have the MSMQ adapter, which would be appropriate for any non-WCF client. If you've got a VB6 application or a C++ app or some other application that's writing messages into a queue, you'd still leverage that MSMQ adapter. This is strictly for WCF clients using MSMQ as a protocol, where the message that gets written on there is going to be a SOAP message or web service message. And then we come to these last two, the custom and custom isolated, which really are differentiated by their host model or their host type. The custom allows you to choose a particular binding and to configure various settings. Custom isolated does the same, but it's in the isolated host or the IIS host. Now, technically, these last two, the custom, are the only adapters you really need. But the reason we have the other 5 is to provide you with that custom user interface and that simplified configuration of those receive adapters. So that, for example, on the WCF basic HTTP adapter configuration, you're simply focused on the core things that you want to configure for that adapter. You don't have to worry about all the other configuration possibilities that are out there within WCF. But these two adapters, the custom and custom isolated, allow you to deal with those cases where you really need full control over the configuration of the WCF properties to be able to integrate or interoperate with a particular client. Now, the message tab of the transport properties allows you to specify the source of the message content. And this is kind of unique within the BizTalk adapters. Generally, you don't have this at the adapter level. But when we have these SOAP messages, you can determine whether you want to get just the SOAP body. That's the default, and that's typically what most people would use. It gives you the payload, if you will, of the message. But you can also choose the SOAP envelope if you want to get all of the message with all the things preserved in terms of the SOAP headers and the encryption and signatures. And you can also use XPath to drill down in and maybe get a particular part of the body. So you may not want the entire payload. You want to use a query to go in and just grab a particular set of data out of the message. Now, when you pick a message like that and you choose the path, you need to tell BizTalk and the adapter what the format of that is, or the encoding of that particular node. So you want to make sure that it knows you're just grabbing some particular XML, or maybe you're grabbing a base64 encoded image out of an XML SOAP message, and you want BizTalk to know that that's a base64 message that it could publish, or hex, or a string. So for example, if you go into the SOAP message and you grab just a string value out of there, you want to let BizTalk know that. All of this is required only when you choose that path option. It's just to help in the processing of the message so that WCF and BizTalk do the right thing. When you have a two-way receive port, you're really talking about a request-response style operation. You're going to get the request message in, and we've seen how that happens with the adapter and the different settings. But when you have a response coming back out from your service operation, then you may want to have some control over that outbound message as well. And so when you have a request response style port, you'll see that you can configure the outbound message much the same way you can the inbound, where you can just send the BizTalk message as the SOAP body. Or if you need to wrap that message in something, you can provide a template. And there's a placeholder in there, this BTS message body, that you can put wherever you need to in the template as your placeholder for where the BizTalk message should go. So this gives you a little bit more control over the message that's going back to the client, so that it doesn't have to be strictly the BizTalk message. It could have a wrapper around it in this case. Now keep in mind that all of this takes place in the BizTalk architecture. So you always have the pipelines and the maps on your receive port as well. So it's possible that you may use this templating model, or it may be more appropriate for you to specify an outbound map if you need to do more than simply wrap the BizTalk message in a template. In this demonstration, we're going to take a look at creating a receive location using the WCF Net TCP adapter. So we'll be listening on a TCP port, and then we'll use a WCF client to submit a message to that endpoint and see it get processed through BizTalk server. In this demonstration, we're going to see how to create a receive location using the Net TCP protocol and the WCF adapters. We're going to start by creating a new application. Call that demos.northwind. And then I'm going to import a binding file that will set up some port information for me. That's going to create some send ports for me. If we look here, I've got 4 new send ports that have been imported. And I've also got a one-way receive port defined. Now I'm going to go in. We can see we have one file receive location, but I want to create a new one-way receive location here. I'm going to call that receive orders TCP. Actually, let me make that match the receive port name. So we'll call it Northwind Receive Orders TCP. And I'll come down and choose the WCF Net TCP binding. And then I'll choose to configure that. Now first we need to provide the address. So we'll call this order service, so we'll use that as the address. And on the binding tab, we'll see this is the custom user interface for the WCF Net TCP binding that surfaces up all of the highly relevant properties that we have here. Nothing we need to change for this, and we don't have to drill down into all the property grids to find those things. On the Security tab, we have a mode that we can choose. And if I switch from transport to message, you'll see that I now can choose the message security settings. And obviously, if I have transport with message credential, then I have some other settings that I can use there, such as using a certificate on the server side that will provide that. We'll leave this at transport and use the Windows security. On the Messages tab, the way I want to handle messages is I want the inbound message, the SOAP body of that, to become the BizTalk message. And notice that the outbound WCF message body is grayed out in this case because I'm doing a one-way message here. I'm going to check these boxes here. These are useful in that I can see suspended messages if I have a problem, and I can also, if I have an exception, the client, which would be my test code in most cases, is going to get back exception details. These are settings you'd only use in development and debugging. You really want to turn these off in production so that you don't have the potential to fill up your message box with a lot of suspended messages. You don't send back unwanted details to the caller. Let's go ahead and start the application. So we can see our receive locations now are enabled and started. Now, if I want to submit something to this, I need to use WCF to submit something. I'm going to pull open a little application that I have here. It's called Submit Order. It's going to take a few command line arguments in terms of what kind of adapter I want to use and an input file name. And what it's going to do is it's going to pick up that file and create a BizTalk message, or rather a SOAP message really, and use the appropriate binding to do that. So I'm going to call this program. I'm going to tell it to use WCF NetTCP. I'm going to pass in the file name, and it's just going to create an XML reader over that and use this API from WCF to create a message. It's then going to use a contract that it's defined here locally to submit the message over to the server. So if we go out now into Windows Explorer, I go into my program here. So I have this submit order WCF NetTCP, and that's going to pick up this order external file here. Open that up with Notepad. You can see it's just an external file. It's this order external. It has some customer information in it. It has some order information in it. And it's going to pick that up and submit the message. The message was submitted. Now we should be able to go to our audit directory and see that we now have this new message that was sent. It should look a lot like what we just looked at with the customer ID there. Obviously, if we switch back over, let's do one more. And you can see that the new message has arrived as well. So we've picked up those messages from that XML file, used WCF and the NetTCP binding to submit it over to the waiting receive location, and then using a standard BizTalk subscription, sent it out to the appropriate send port and delivered it to the file system. For our third lesson, we're going to look at using the WCF Service Publishing Wizard. So we'll see what the various steps are that are involved in publishing a WCF service or exposing it out. Before, we saw how to just simply create a receive location with the NetTCP. Here we'll see how we can publish things out, such as configuring an orchestration so that we can publish its ports out as services. We'll see the mechanics of using the publishing wizard, and then we'll walk through a demonstration of how to publish a WCF service. And finally, we'll talk a bit about publishing schemas as WCF services. So we've got the notion of publishing orchestration ports, but we can also simply publish schemas and create metadata information and endpoints out in IIS. To publish a WCF service, by starting with an orchestration, we want to take that orchestration or that business process, and essentially our goal is to create receive ports that allow messages to arrive over WCF or over a SOAP messaging infrastructure. And so when we publish that, we want to do a couple of things. We first want to make sure that we have the mechanics and the infrastructure set up in BizTalk such that messages arriving will be correctly routed into the orchestration. But we also want to have that service, when we publish it, expose out a web service description language or WSDL document for clients. This is going to allow the clients to consume all of that metadata about the port names, the operation names, and the various message schemas so that they can create their own proxies or their own client representations and be able to send messages to this service. So we'll first need to start by building out our BizTalk project, of course, with schemas and the orchestration. We'll need to correctly configure the orchestration ports, and then we'll need to set up the physical receive port and location. We'll run the publishing wizard to go through and hook all these things together. And then we'll need to make sure that we configure an application pool in IIS. And this is important because the application pool needs to be running as an identity that has the appropriate access to BizTalk server. It needs to be able to read configuration information about the received locations, and it needs to be able to submit messages into the BizTalk message box. Now in an orchestration, we model out receiving messages by using ports, but by default those ports have an internal scope. They're really scoped to that particular orchestration. And that doesn't really cause a lot of problems until we get into wanting to share ports across orchestrations or across projects, or when we want to expose that port out as a web service. In order to do that, we have a requirement that the receive port must have its access modifier set to public, so that we've explicitly declared that we want this to be something that is exposed externally. This is going to allow that orchestration to receive messages from web services. This is important to remember because most people don't run into this if you're using a file adapter, for example, or any other kind of adapter. We don't necessarily have this requirement that the receive ports be public. But as we'll see when we walk through the wizard, it is required that those ports be public so that we can see them outside of that type and use them in declaring that WSDL. To start this process, we've got our orchestration, we've built it up. Now we need to run the WCF service publishing wizard. And the job of this wizard is to, in the case of orchestrations, look at our orchestration, find those public ports. That port is going to provide the information about the various operations and the messages that we're exchanging. What are the request messages and the response messages? And it's going to take that information from the orchestration and create for us then the artifacts we need to host in Internet Information Services, or IIS, in terms of a service endpoint, the service description, and some configuration files. And that metadata then will be an optional piece. So we need the hosting and IIS of the service endpoint and its configuration to make sure that messages arriving at that endpoint can get into BizTalk and to our orchestration. But we also have the ability to publish that metadata that the clients can then consume and build their own proxies and be able to call our service. In this demonstration, we'll see how to publish an orchestration as a web service. So we'll see how to set up the orchestration correctly, how to run the wizard and go through the steps to publish out the orchestration and its metadata, and also how to make sure we've configured the application pool so that the adapter code running in IIS will be able to read configuration and submit messages to BizTalk. In this demonstration, we'll take a look at using the WCF service publishing wizard. What I have here is an orchestration that receives an order, sends some information off to two different ports, the billing and the audit ports, and then also looks at the message itself, look at the shipping destination, and might send some things off to a USA send port or an international port based on that information. And what I want to be able to do is expose this port as part of a web service endpoint. Now that order receive port, if I look, has a type of order received port type. And if I go and look at that, the type modifier is currently internal, and I want to change that to public. I want to make sure that that type information, that port, is going to be public so that when I run the wizard, it will pick up that port and allow me to see it and allow me to expose that in the orchestration. Now I'm going to come back up and I'm going to deploy this solution. And that's going to go out and, of course, deploy all the artifacts to the global assembly cache and get all the metadata updated for me out in BizTalk Administration Console. While that's working, we'll go out and start our wizard here. I'm going to go under BizTalk Server 2010. And you'll notice there are two wizards. There's the WCF Service Publishing Wizard and the Web Services Publishing Wizard. You want to make sure you get the WCF Service Publishing Wizard. The Web Service one is a legacy one that shipped with BizTalk 2004 and is now deprecated. So we'll start up the WCF Wizard. There we go. You see in the background, it looks like our deploy may have finished as well. So as we start the wizard, we're going to choose first the adapter type. You'll notice that these are all isolated adapters. If we're going to create an endpoint out here, it's going to be one that's hosted in IIS, and so we're going to use the HTTP focused or the custom isolated here. And we're going to, on this one, use the basic HTTP. Now I also want to enable the metadata endpoint. I want to enable the publishing out of that metadata so that somebody can browse to it and build their client proxy. And I'll have the wizard build for me in my Northwind application a receive location that will already be configured with the appropriate values that we generate from this wizard. Now I want to publish my orchestration. So I need to browse out to the assembly file. We'll go into that module. We'll get into the orchestrations here. And now we can see there's our order receive port that's been exposed and listed there because we made it public. Now if there were multiple orchestrations in there, we could pick and choose. We could decide if we wanted to take all of the different ports and include them in a single WCF service, or if we wanted to publish them out in multiple services. Now that we've chosen our port, that gives us all the information about the port. We also need to specify a namespace now. So we'll do northwind.com/orders. And here then I want to specify the path within IIS where I want to host this. So I'm going to use port 8080 because that's where my website is that's hosted. I'm going to call that Northwind orders. I'm also going to choose to allow anonymous access to this service, so it's not going to require authentication. And this final page is going to show me in the service summary that it's all ready to complete that and to build up the artifacts I need to host my web service. Now that it's finished, I could click finish, but first I'm going to click this link here, as that's going to take me to the generated code. Now that I have that, I'll go ahead and let this finish. And so if we look, we can see we have an SVC file here. We have a web config file as well. If we open up the app data, we'll find the XML schemas and some of the other things that were pulled out of that orchestration that are here and help us in building up the metadata. Now, if we come back over here and we open that up, we'll take a look at the SVC file that was generated for us. And you can see that it points to a custom service host factory, and it has a no service element here. This particular BizTalk artifact is going to create the appropriate host for us and dynamically accept those messages and submit them then into the message box. So it's going to use that adapter code to submit those into the message box. We'll refresh that. Now we can see we have a new receive port. This nice name, WCF receive port Northwind orders. And then it uses the information of the namespace and the name of the orchestration and the port to add all that information in there. We look in the receive locations. We now have a new receive location. We can look at that. We can see it's configured correctly with the WCF basic HTTP adapter. And if we configure it, we'll notice there's our virtual directory that we created, and here's the name that was generated for the SVC file. And so it uses a virtual path as the address here, which means our BizTalk configuration isn't tied to a particular server or port number. And we can also look at things like the binding and the security and the other settings that are applied there as we did previously. Now, if we go into our newly created receive port, we can also set up our maps here. So we can set up our external to internal maps. So I want to, even though I'm receiving over WCF, I still have the ability to apply maps and other things. Now I'll configure the application. I need to set up for my orchestration the ports that we want here. So I'll choose that new port that we've created there. For the order billing send port, choose the send to billing. For our audit, and for our USA, and our international. So now we've got all of our ports configured. Everything is happy there. We should be able to start that application. Now we've got the application started. Everything is configured well, except we need to go out to IIS now. We'll find our virtual directory that was created by the wizard. And we'll need to set up the correct application pool because we want to make sure that our site out here with our Northwind orders, we want to make sure that particular application is running under an account that has the right credentials. We can see right now it just went into the default application pool. And so I want to choose to run that under this BTS-WS pool. That's an application pool that I've set up that's running as a BizTalk account, an account that has all the privileges to be able to read the configuration and submit the data into the message box. So we'll go to the content view here and we'll browse this, and we'll just make sure that we get that documentation page and the metadata here. So there we can see we've got that documentation, and we have the WSDL then that we need to be able to build client proxies for this service. Now that we have that information, we can test our service. Oh, we don't want the web root. Let's go over here to our module 13. And this time I'm going to use a different command. This one's going to send the request, and it's going to use that basic HTTP binding and that new endpoint that we've created. But in the end, we should then see messages come out here through the billing department. So the file was submitted. Watch for it to come through, and now we can see that it's arrived on the other side. It's actually come out as a text document. There's our order. It's been converted from an external order to an internal order and come out through our subscription. So we've used the service publishing wizard to publish out the endpoint. We've exposed metadata on it. We made sure in IIS that we were running under an account that had the appropriate rights, and we configured in BizTalk Server the receive location that it created, and we hooked all of our ports up appropriately on our orchestration. We've seen how to publish an orchestration as a web service, and that has the benefit that the orchestration already defines really the logical entry points in terms of the port and the operations. However, BizTalk also supports using WCF purely at the messaging layer without any orchestrations. In that case, we can use the wizard to publish schemas as our web service. Now, this requires then that we have to describe the service. So when you use the wizard, you'll describe the web service, you'll declare the different methods, whether they're one-way or request-response style methods. And then for each method or operation on the service, you would also use a schema to specify the request message or the response. You can see here in the dialog, the response message type is being chosen. And so it's more of a manual process of identifying all the things that were explicit in the orchestration port. Now we need to add in here to include that information in the processing and in the metadata. Now when that message arrives, we haven't run through the wizard for the orchestration. We're not really configuring things for an orchestration. So when those messages arrive, you can use standard message routing, message processing in terms of pipelines and maps on those messages, both the one-way and request-response style messages. As you work on the lab for receiving messages with a WCF adapter, you'll see how to publish a schema as a web service, and then you'll also be able to use a client that will consume the service, and you'll be able to test that your messages are arriving at BizTalk Server and getting processed just like any other message would coming into your BizTalk Server application.